Okay, students, we're going on now to question 5 from this 2020 sample paper, the State Exams Commission sample paper. So this is just a one-sided question, so I'll leave that there as a reminder of what we're doing. Okay. In the coordinate diagram below, 16 points are marked with a dot. Excellent. An excellent language. Yes, they are. That's what you do. You mark points with dots. I like that word. Okay. Louise picks 1 point at random from the 16 points. Okay. Marked with a dot in the diagram. She then finds the equation of the line that goes through this point and through 0, 0. She then finds the equation of the line that goes through this point and through 0, 0. So she's finding the equation of lines like that one or that one or that one. Like that would be an example. Find the probability Louise's line has a slope that is greater than 1. So you need to understand that this has a slope of 1 and that lines through which are not greater than 1, none of these will count. So this is all the outcomes. There are 16 of them. In other words, the number of outcomes equals 16, and the number of the events. Okay, now what are events? 1, 2, 3, 4, 5, 6 equals 6. There are 6 events because that will give us slopes. You know, that'll be the smallest slope bigger than 1. That'll be the next. That'll be the next, etc. Okay, there'll be one there. There'll be one there, and so on. Okay, there are 6 of them. Find the probability Louise's line has a slope greater than 1. So the probability, this is not in the log tables. We can go looking for it. There is a place for probability, and let's just make sure I'm not wrong here. So geometry, indices, sets, standard deviation, mean. So let's come out here. Statistics and probability starts on this page 33. Probability distributions. This looks like very, very advanced binomial distribution. It's a Leaving Cert concept. It doesn't have the formula we're looking for. Poisson distribution, sampling. So there's nothing out there for us to go to the log tables. So we have to just know this formula off by heart. And it's the probability that an event happens. Okay. Now an event is a subset of the sample space, and sample space and outcome mean the same thing, are all the set of outcomes and sample space. So the probability of an event happening is equal to the number of events. Now you recognize this thing. This is the cardinality of a set, because events is a set. So the number of elements in the event set divided by the number of elements in the outcome set. So our outcome set had 16 elements in it, and our event set had 6 in it. Okay, so that should be pretty clear, and that goes in at 6 over 16, which reduces to 3 over 8, which reduces to 0.375. Checking. Okay. Now I could have said probability m larger than 1, slope larger than 1, equally as to name the event in particular. How many of the 16 points marked with a dot in the diagram are a distance of exactly 5 units from the point 0, 0? This is where knowing your Pythagorean triplets could be so important. Okay, if I go out three inches and I go up 4 inches, I'm not going to have it there. If I go out 4 inches, I go up 3 inches, I'm going to have it. No, okay, but basically, if I go out 3, 1, 2, 3, and I go up 4, 1, 2, 3, 4, then this is 5. And sure enough, this was 4, and I have another 1 there, and this was 3, and I have another 2 there. Okay, so it's 3, 4, 5. Why am I saying that? Because to get 5 away from the origin, you can't go out 5 because it's off the scale both ways. So you have to go out 3 and up 4, out 3 and up 4 to that one, or out 4 and up 3 to this one. So both of those will be 5 away. Okay, so 4. If I just eyeball 5, it'll be about there. And sure enough, if I go from here now, scooting up through them, it'll be 5. Okay, once I do it accurately. So how many of the 16 points? The answer is 2. How many with a dot, marked with a dot are a distance exactly 5 from thing? 2. And we can be, they didn't ask me, but I can just show off a little bit and say 4, 3 and 3, 4. So that's where knowing your c squared equals a squared plus b squared from your Pythagoras formula, page 16, a, b, c, and then just knowing that there's a very special case, 3 squared equals 3 squared plus 4 squared, called a Pythagorean triplet. Another case is 13 squared equals 5 squared plus 12 squared, quite popular. Not talking about that now though. Okay, are we done? We're done. As always, I'll see you in the next one.